You undoubtedly know some things about global warming and climate change. Perhaps you know quite a lot about it, or perhaps you know a little bit. I'm not going to attempt to cover this topic comprehensively. That would be more than a single course. But there are a few key points I want to cover to make sure we're all aligned in common understanding. The first thing to understand is the theory of climate change. What's a theory? The conflict is well stated on the website of the American Museum of Natural History. They say, in everyday use, the word theory often means an untested hunch or a guess without supporting evidence. But for scientists, a theory has nearly the opposite meaning. A theory is a well-substantiated explanation of an aspect of the natural world that can incorporate laws, hypotheses, and facts. A theory not only explains known facts, it also allows scientists to make predictions of what they should observe if a theory is true. Scientific theories are testable. New evidence should be compatible with a theory. If it isn't, the theory is refined or rejected. The longer the central elements of a theory hold, that means the more observations it predicts, the more tests it passes, the more facts it explains, the stronger the theory. So as change makers, we need to be on the lookout for this gap in the understanding of the word theory. When people cross meanings, when they apply the common meaning to a scientific use of the word, that is when climate denial sets in. The scientific theory of global warming has been tested repeatedly since it was first presented in the work of Eunice Fenton Foote in 1856. Decades of observations and tests have supported and refined this scientific theory. By the standards of science, the understanding of global warming and climate change grows stronger with every year. Climate change is an existential crisis. It threatens the very existence of humanity. Even though I'm writing this while under statewide COVID shutdown, climate change is far more dire threat to humanity than a global pandemic. Renowned climate scientist James Hansen and his team said, if humanity wishes to preserve a planet similar to that on which civilization developed and to which life on Earth is adapted, paleoclimate evidence and ongoing climate change suggest that CO2 will need to be reduced to at most 350 parts per million, but likely less than that. What Hansen was getting at is that life forms on this planet have never had to cope with such extreme conditions as climate change at its worst are forecast to bring upon us. The phrase climate change sounds so mild. Global warming? So what's a few degrees? Don't we all like a sunny day at the beach? Rather, what we're beginning to see might better be called radical climate disruption. Climate includes rainfall, snowfall, precipitation, rainfall that waters fields and agricultural crops, rainfall that grows forests, snowpack that feeds city water supplies, precipitation that fills aquifers, feeds the source of wells. Climate includes whether we will have searing heat days or incredible chill in which nothing can grow. Climate turmoil is changing the flow of massive currents such as El Niño and La Niña, which drive weather patterns worldwide. We're seeing extended regional droughts. Seasonal storms are causing worse flooding than ever before. Climate change is melting glaciers, and that cold water flow is disrupting massive ocean currents that wrap the globe. You can think of it like the ocean circulatory system. This is upsetting salinity, the biochemical properties within the seawater, and that biochemical upset is devastating many species, including corals and fisheries. Melting glaciers combined with increased temperatures are leading to sea level rise, which is beginning to erode coasts around the world. Massive swaths of land, which even the earliest historical maps have counted on as dry land, are beginning to disappear underneath the oceans. We're losing entire island nations. Changes in climate are driving the spread of many diseases such as malaria. It's coming into areas where it's never been a problem before. Scientists say the future pandemics are increasingly likely because of climate upset. We're seeing what we would call pandemics in other organisms as well, such as the spread of a little insect that carries a citrus greening disease, which is devastating U.S. citrus and may mean the end of your morning glass of OJ. Every time I've mentioned weather, think about farm crops. Think in terms of food supply. Your food has to grow somewhere. Right now, we're in a climate catastrophe. The steady, sedate weather patterns that farmers have relied upon to grow food crops, weather patterns that humanity has relied upon since the dawn of the agricultural revolution in prehistory, are being thrown into turmoil. We're seeing record extreme heat days, record deep freeze, record wildfires. We're seeing record Category 5 hurricanes to the point that scientists may need to add additional categories to the hurricane scale. And all of this is driven by burning fossil fuels, crude oil and its derivatives, natural gas, and coal. This diagram was created by Michael Mann and has become known as the hockey stick. See the long handle with a sharp rise. It's based on carbon dioxide levels. CO2 is the chemical abbreviation. These are observed in real-time measurement stations around the world and from tree ring studies which go back hundreds of years and from ice cores drilled from glaciers which go back centuries. We see that for most of the course of recorded history, CO2 levels were rather steady. And then we have this huge spike. The spike begins right about the time of the Industrial Revolution, when mankind began burning huge volumes of coal. I mentioned climate scientist James Hansen before. The models of Hansen and his team calculated that there was an ecological limit to how high these emissions could go before a series of interconnected catastrophic disruptions would begin to occur. Hansen and his team calculated that this limit was 350 parts per million. As I write this, the level of CO2 concentration in the upper atmosphere is at 415 parts per million. In more recent studies, Hansen's team and others have calculated that we may be able to avoid some of the worst disruptions if we rapidly pull those CO2 concentrations down below 350 parts per million. This is currently the international understanding. What does that 350 parts per million figure represent? Scientists are talking about CO2 concentrations in the upper layers of our atmosphere. That's where the greenhouse effect does its deadly work. Every time we burn anything down here on the surface of the planet, but particularly when we burn fossil fuels, we emit CO2 particles. These invisible gas molecules rise up into the upper atmosphere. So what's the difference between carbon emissions and CO2 concentrations? Well, think of it like your kitchen sink. Say I turn on the faucet slightly. The water pours in from the faucet, but it drains right back out of the sink. There's no accumulation. That's how it was before the Industrial Revolution. The faucet is like our carbon emissions from burning stuff. The drain is like the natural planetary systems for cleaning up the gases from burning stuff. Back when the Chumash and the Kizh and other indigenous peoples stewarded the land of Los Angeles, gases from small cooking fires were no big deal. Nature kept things in balance. But along came the Industrial Revolution. Suddenly, that faucet got turned on full blast. As the industrial ascent continued, it was like adding more and more faucets and increasing the water flow. What do you think happened to our poor little sink? Nature was still trying to clean up the gases, but there was a limit to how much she could do. Meanwhile, humans discovered ways to extract huge amounts of coal and then oil and gas and began burning more. Our poor sink got overloaded. The drain could no longer handle it. The water level no longer drained away. It began to accumulate, to back up. That's CO2 accumulations in the upper atmosphere. Humans added cars, freeway, air traffic, more. At this point, our sink is filling fast, up to 415 parts per million. What scientists are telling us is we need to get our sink back in balance. We need to, quote unquote, turn off the faucets, which in real life means dramatically slashing carbon emissions. We need to, quote unquote, pull the plug, which in real life means increasing carbon sequestration by planting trees, restoring forests, growing living soil, which we'll talk about in a later portion of the course. If you begin to monitor CO2 concentrations, you'll learn that they fluctuate seasonally. Some people say this is comparable to the planet breathing. We're looking for an overall trend, a moving average. And once we understand the kitchen sink example, we understand that we have a long-term project on our hands. This is not something we can fix with a few, quote unquote, more efficient engines. We need to drain that sink back below 350 parts per million.